All right, welcome back, everyone. Today we have a very exciting lecture prepared for you. We have two demos today. One is lock picking that I promised, and the other is the Internet Explorer 8 exploit demo. So we'll get to that very quickly. Before that, a couple of announcements. First of all, next Thursday, we have Salman, our TA, giving a short guest lecture on COVID WISE. Please install it if you haven't. This is our state-sponsored app for tracking COVID infection, and learn about it. If you haven't heard of it, you can download for free, and Salman will explain how it works, why it is safe. It's completely privacy preserving, so we'll get to that next Thursday. Also, if you would like to study that for your class project, you're very welcome to do so. Next class, I want to say a little bit about class project. Video lecture, I know this is a very difficult semester, so and just hang in there. 2 video lectures per week, unless there's some special circumstances. I try to upload one on either Monday or Tuesday, another one before the end of Thursday. I'll definitely announce the new videos will be put under Media Gallery on Canvas and on YouTube, and I'll make them available on both places. It'll be easier if you subscribe my YouTube channel. I have made all the videos public instead of putting it unlisted. It just, I want to make it easier for students to access the lectures. And 2 assignments are out. One is a weekly summary. The other is the 5-minute video presentation on cyber incidents or cyber defense, and so make sure you check that on Canvas. I also want to say that because this is a very difficult time, this is a very special time, and you have to really change your behaviors. Watching lectures is not like watching a TV episode. If you watch TV, you can eat popcorn, do other things, cleaning dishes, but you have to find a quiet place to watch lectures. Make sure you have consecutive an hour time during a day that you're relatively awake. Take notes. I encourage all of you to take notes, and just don't just listen. Okay, it has to become yours. The knowledge has to become yours. You owe it. So take notes, treat it very seriously. And you sort of, maybe the first few weeks, you kind of practice how effective, try different ways. Maybe you watch the lecture, and here is actually more effective than watching the lecture on a dining table. So find out the best effective way to learn. I do ask the questions. P.S. Many of you have signed up. If you haven't, do sign up, and I also want to do some polls. Once all of us are there, polls or online quizzes, either through Pieda or Google Form. So communicate. One thing that I like to do today is to do a quick sanity check, a few questions, true and false. Follow along as you go. So true or false statement: security is relative. True. One can achieve absolute security. False, right? And because we talked about the viruses, for example, is adaptive. It's could change its behavior, and a lot of times that in reality, attackers will try to circumvent your detection. CIA, AAA are those acronyms. So what kind of security properties this stand for? CIA. You should know that. Confidentiality, integrity, availability, authenticity, anonymity, assurance. Okay, so say it out loud. Yeah, and Salman, could you say it out loud with me together? Okay, yeah. 3, 2, 1. Confidentiality, integrity, availability, authenticity, anonymity, assurance. Thank you very much. One mitigation for ransomware attacks is backup. True or false? True. Right? It's very important you back up so that if you're like it's reduce the risk of having to pay ransom. A secure coding practice is to always validate input. True. Because inputs are just not very trustworthy, okay? And it could be hijacked, could be people attackers inject from the internet. And by the way, if you're really confused, go back to our lectures, okay? Everything is covered. Those are just a very basic concept. Cipher operations involve A, substitution, B, permutation, C, both. Both. We explain you just have to do both of them, both type of operation to make your cipher attacks look as random as possible. Otherwise, it's very predictable. A cipher encrypting a word, say Midway, as in Midway Island, always the same way, you encrypt the same word, always the same way, is not secure. Like if you encrypt Midway as AF, refer to that as AF all the time, yesterday, today, tomorrow, it's not secure. True, right? So it has to be changing. Like a lot of times that our Wi-Fi communication point it changes all the time. The older version WEP is so broken. Part of it is because it's always encrypted the same thing, same way. The last question, drum roll, please. When analyzing the security of a solution, it is extremely important to figure out the threat model. In other words, understand the attacker's capabilities. True, it's very important, threat model. Just you can never, it's never really useful if you say, oh, my solution is secure, period. And it's not very useful. It's secure with respect to some type of attack. And so you really have to explain the boundary of your threat model. All right, so that's the quick online sanity check questions. And in last class, we talk about software security and mention these concepts and make sure that you familiarize yourself with that. Today, I want to talk a little bit about web and network security, and also still very basic, just the introduction. We'll go into the details sometimes in late October. And a lot of these are still because the threat model is limited, and so attacks fall outside the threat model that cause problems. So one of them is forms, which we'll talk about later. And so right now it's the exciting demo component of today's lecture. So we'll have Yang showing how to break back combo lock. And yeah, we have talked about the particular lock problem and show that in theoretically the brute force, how long did it take? But then because it's poorly designed, it's a lot easier to break. So go ahead.
Hello everyone. Today I will show you how to break this bicycle lock within 1 minute. You can see there are 4 mirrors and each one has 6 numbers on it. So theoretically it has 6 multiply 6 multiply 6 multiply 6 combinations of its passcode. However, in practice, we can break it with 6 plus 6 plus 6 plus 6 attempt at most. Let me show you how to do. And if you have a bicycle lock at hand, you can follow me. First, we need to figure these numbers out one by one from the left to the right. And let's focus on the first wheel, the very left one, this one. And we need to pull it hardly. And you can observe that this one, its left gap become larger under my tension, this gap. And we need to pay attention to its right gap, this one. And you can see here, it doesn't change. So I rotate it to, oh, sorry, this side, this gap. And I rotate it to another number, 1. And this gap, it doesn't change. And 2. I can observe that it become obviously larger. This gap, not sure whether you can see it clearly.
Yeah.
So that means the number 2 is the correct number here. And let's move on the second wheel. And also,
so essentially, you are able to tell digit by digit what is the correct value, and then by telling by examining the gap between the wheels.
And this time for the second wheel, we focus on its left gap become larger under my tension, but its right gap does not. So
if the number is correct, then you will observe a larger gap at some place. If the number is like incorrect.
For the number 1 here, I can observe that this gap, it becomes larger, slightly larger. So this time I move the third wheel. And I can see here, the right gap of the third larger at the number 3 become larger here. So I'm on the last wheel. So we got it, and the correct number is.
All right.
I want to add a little bit, like so the newest lock, they have some false gate as well as the true gate. So you will observe the gap in the false gate as well. So in that case, probably 1 true gate and 2 false gates. So you will have 3 options for a single number rotation. So then you will have more, like you need some combinations to unlock it. Then it will not be 6 plus 6 plus, like it's like probably 80 on.
How many?
80? Yeah. So right now it's you need to like 6 option for a particular.
But it's 24.
Yeah, but that particular setup you need 80 on attempts. Like if you have on true gates and 2 false gates, in total 3 gates. So now the latest locks has 2 false gates as well. So that in the false gates, you will also observe those gaps. So you cannot tell which one is true gates and which one is false.
So how many altogether guesses in the new lock the attacker has to guess in the worst case?
In worst case, they need to make 80 on attempts.
You said 80?
80 on, yes, 8 on, 80 ons. 80 on. Like 9, 3 times.
81?
3 times.
81? Oh, okay. Okay, got you. All right, thank you so much. Yeah, appreciate it. So bye. Simon, you want to go ahead and share your screen?
Yeah, sure.
Simon, make sure you open your mouth a bit so it's easier to hear, because the recording sometimes is harder to hear.
Okay, sure. So you can see my screen, right?
Yes.
Okay. Okay, so good afternoon, everyone. So In this demo, I'm going to show you how attackers can use software vulnerabilities to compromise a system. The software vulnerability that I'm going to show in this demo is called use after free. So the use after free vulnerability happens when programmers use like dynamically allocate some objects in heap, freed those objects, and later dereference those freed objects. And now the actual exploitation process is slightly complicated and lengthy, but the high level overview is when attackers dereference freed objects, it allows attackers to, sorry, when programmers dereference the freed objects, it allows attackers to override the chunk header and the unlinked pointer of those freed objects, because when this freed object is allocated in heap, it has those headers and link pointers. So it allows attackers to override those link pointers. Then the attackers can override the link pointer to point to their custom code, such as the return-oriented programming, gadget chain, or shellcode. So to show that show you the exploitation process, I'm using a exploit module from the Metasploit, which is publicly available. You can download it and run this exploit in your machine as well. Now, to show the exploitation process, I'm using two virtual machines. One is for the attacker, which is a Linux-based machine, and another is the victim machine, which is a Windows machine. Now, this exploit is particularly related to the Internet Explorer 8 because Internet Explorer 8 has a use after free vulnerability. Now, the idea is the attacker will set up a malicious server in his machine, create an URL, and send that URL to the victim machine. When the victim access that URL using Internet Explorer, it will create some back and forth communication with this attacker's machine. Basically, it will the Internet Explorer will pull some code from the victim machine. That code will have the exploit code to exploit the Internet Explorer, and eventually it will compromise the host. Now, since we are using an existing exploit from Metasploit, we just need to issue a set of commands to run this exploit, and also the setting up the malicious server. So now I'm going to set the malicious server, which is I just need to use what kind of exploit I'm using, which is I'm using a exploit from the Windows, and it's from browser, and it's called iexec command UAF, which is use after free. Now I need to set up the payload, which is basically responsible for creating the backdoor from the victim machine to the attacker's machine. This is called meterpreter reverse TCP. And then I need to set the local host, which is the IP address of this attacker's machine, and set the server host, which is also the IP address of the attacker's machine as well. And so once I have this set up, if I just issue the exploit command, it will create an URL. Now attacker will send this URL to the victim machine. Now this process, sending process, can be done using spear phishing or just phishing techniques. I'm assuming that the attackers has already done this and send this URL to this victim.
And the Metasploit is a known framework for
Yes.
anyone to use. Is public, and so for the attacker doesn't have to the attacker doesn't have to write a Metasploit, and the for the particular exploit code for this one is public available. You didn't write it, right? So it's
no.
just to get it from the
So this is only one exploit, but a Metasploit has like thousands
many
of
other exploits. Yes, and so this is just to show how easy it is for someone to to set this up.
Yes.
Yeah, continue.
Yeah, so once the attacker has this URL, it sends to the victim machine, and once the victim access that page using that URL. Let me type it. So it's X.
And right now it's a victim. We are running a two separate virtual machine. This one represents the victim's virtual machine, as Salman has said.
Yeah. So once the victim access this URL using Internet Explorer 8, it will create some back and forth communication, which is basically create the backdoor from these victim machines, which is basically exploit Internet Explorer first, then create backdoor from these victim machines to the attacker's machine. That will allow the attacker to access everything from these victim machines. Now, once this back and forth communication is finished, we'll see how to access the victim machine. So just to show you, we have a folder called cyber in the victim machine's desktop, and inside it we have a files node. It just has a hello text. So we'll see how we can access this text.
And this is just this is already outside the victim's Internet Explorer. So
Yes.
it's not like, you know, okay, my browser got infected, my browser is crashes, and nothing else is impacted. But here, what Simon is showing that there the attacker will be able to control the computer.
Yes. So I think the background communication is done, and we see there are some sessions, the backdoor sessions here. If we use one of them, and if we type the shell, so we are basically in the shell of this victim's machine. Now, if we just issue the dir command, which will show all the files in the desktop folder, we see the cyber folder here. If we go into the cyber folder and issue the dir command, we'll see that the node.txt file, and if we just it's equivalent to cat command in Linux, which is the type.
Yeah, because
so
this is your Windows, right?
Yeah, I see the hello text here. So this is how attackers can compromise whole system using vulnerability like use after free.
Yeah, and if you have say cookies storing sensitive information, credit card, and this can be accessed by a remote attacker. And so I noticed that the internet, the victim's browser shows an error message. Is this so is this indicating, like, sometimes you know so is in terms of conventional wisdom, okay? So if you visit a website, you get an error message, is that does that look suspicious?
I would say so, yes. That definitely, if browser accessing something and shows this kind of error, it definitely doing something it's not supposed to do.
Out of ordinary, yeah.
Yes.
Yeah. And so is there any way for attackers to hide this error message and like exit gracefully? Do you know?
Yeah, I think this exploit is very old, so it's not that robust. So I think the robust exploit will have options to do everything purely on background without
it's like invisible to
Yes.
the naked eye in the exploit. Yeah.
Yeah.
All right. Well, so thank you so much. And this is the much older version, IE8. Right now, IE is yeah, there's no obviously this kind of glaring holes in current Internet Explorer.
Yeah,
So,
I think Microsoft also has completely replaced it with another browser, the latest browser. I just forgot the name, but
okay. So would you say that patching is very important in
yes.
a way, so that because this is a public available exploit, if people don't patch and then they run legacy systems, and then, anyone on the internet will be able to launch this exploit?
Definitely yes. Yes, so the passing is very, very important. Like,
Yeah.
like updating the system whenever the update is available is very
That's
important.
right. Updating the system and also make sure don't fall victim to phishing attacks and
Yeah.
phishing emails. Don't click on the links and don't click on the links in the in suspicious looking emails. And always use and then part of it, if you have say medical records, if a hospital maintain medical records, maybe they should also encrypt the files, and so that even though attacker get hold of the files and they cannot decrypt, that will be another mitigation to reduce the damage of this attack.
All right. Yeah.
All right, that's great. And so that the last bit of discussion, I just want to for all to get more intuition in terms of multiple ways that people can do, and because the attacks look like it like this look extremely dangerous, and you feel like, oh, this is it's completely hopeless, but then there are many ways for you to keep up your system and protect the system. All right, excellent. Thank you so much, Salman.
Okay, yeah.
Bye.
Bye. See you.
All right, so let's continue our discussion. And because of the video, the lecture, and I want to switch up a little bit once in a while, so that just make it more interesting to you. In terms of the internet security, it's very important to know that you don't trust the information you get from the internet. Okay, the form, you don't trust it, you sanitize it. And one of the biggest data breach in US history is, of course, Equifax. Okay, in 2017, half of US residents, the most sensitive information got stolen, compromised. Like we're talking about 1 out of 2 Americans. And so and because we said, okay, security is you cannot achieve absolute security. So but then people find out Equifax data breach is just very stupid. They first of all, they didn't patch for like months. They didn't patch it, and then the exploit was available on the internet, and eventually I think the vulnerability was reported in March, and then they only patched in July. And then researchers also find out their website has all kinds of issues. One of them is a cross-site scripting vulnerability, and this allows people to put up windows of their control. Okay, and you look at so there are certain places you enter a form. Look at this in the background. This is form. But if you don't sanitize a form, it allow attackers or researchers to inject JavaScript code, and then when you display the form content, because in your list you say you have submitted this as your address, and so you render the information submitted by the client, you effectively executing JavaScript code. So not just one, other people find that they have other websites that has this issue and reported in 2016 and never get fixed, at least as of late 2017. And so it's just rigged with issues. And clearly you see, okay, this organization that sit on millions, hundreds of millions of people's most sensitive information. And first of all, this is, you probably don't care. Your parents will have to get a credit score from there in order to get mortgage. They at least didn't pay any attention to security, which is extremely sad. We'll talk about that also throughout the semester. The network security is very important. It's for client and server model. Most of the time, it's client and server. Right now, a lot of servers are in the cloud, but it's still you are a client. Your phone is a client. Your browser is a client, and you talk to a server to get information, to store information. And so you have an IP address. You can find out your IP address. It's very important that there are many entities between you and the server, okay? And so you know who they are, who control them, how secure they are. And so you don't want your most sensitive information, your bank account, credit card information, your email content to be accessed by those routers and the gateways. Because even though the administrator controlling the router is trustworthy, but the router could be hacked, right? So very similar to a postcard. I think a lot of times the network communication, like email, is very much like postcard. So you don't put your credit card number, your social security number on your postcard, right? So same thing, you don't put that information in your email. And so a lot of times that we, in network security, we talk about end-to-end security. One end is the sender here. The other end is the receiver, okay? So, let me see the, when we talk about the technical details about network security, we'll TLS and SSL will talk about how specific steps to achieve this. And as a matter of fact, one of my big goal in this class, so one of our big learning objective is for you to get familiar with TLS. Like how to do end-to-end encryption, because it's happening every day. It's very important you know how it works. So don't send sensitive information in email, period, okay? A lot of times that you, so where, how do you send it, right? It's tough. It's sometimes I would say the canonical way, the right way to send it is to do encryption. Okay, I encrypt using, if I need to send a form to one of my staff, I will get her public key and then encrypt the form with my social security number in it, use her public key, and then she decrypted with her private key. But she may not have a key pair to use. So a lot of times that people say, oh, you just call me, you send everything else and you call me with your your social security number. And so assuming attacker are unable to intercept both. And so that would be a good mitigation. You just, again, you just make it harder for people. But so we want to lead to the TLS discussion. So today I want to, throw out, for you to start thinking about authentication, who authenticate first. So, but first, what is the server's biggest security nightmare? And then you may not care too much right now, but you may graduate from here and then get a job and maintain your job, maybe maintaining a server. That will be your security nightmare, okay? So your nightmare will be the client may be a hacker, okay? So if everyone behaves very well, then certainly that would be nice. So denial of service attack is obviously a very common attack. And the hacker just do multiple communication, just to open up sessions automatically connecting to a server. And server is so exhausted, it won't be able to serve legitimate users. But a lot of times that, if a hacker has a server, may not be very powerful, the attack ability, how many sessions would one computer open, right? So if you assume hacker has one computer, then you just have two computers, and then you always have this additional computational bandwidth. So that's why the DDoS most of the time is what attacker uses. They have free computers to use, those botnet, zombie computers and compromised computers, and they use those to infect, to launch the attacks. And as we mentioned multiple times, many botnets, they were used by sold out to people who need to launch DDoS attacks. And they utilize all these distributed compromised computers. So a quick sanity check question under distributed DDoS attack, what security property of the server is disrupted? The answer should be C, right? Availability. Another threat is, of course, the hackers send the malicious code in the request, like the cross-site scripting, right? Instead of submitting a form, the hacker submits some code, and then the code may be able to remotely execute, like what Salman has demonstrated. So on the flip side, what does the client worry about? The client worry about not be able to talk to the right server, okay? When you enter your information, I was the other day tried to enter Yahoo. Yahoo had a data breach, and I during that time had a Yahoo account, and I think last month I got an email saying, oh, you should oh, it's not Yahoo. Yahoo, that was separate. I was also in the Yahoo data breach like class lawsuit. It was a Google Plus, and so as part of the class lawsuit settlement, the victims, all the users had the compromised impact by the data breach, has to enter some bank account into a website. And I was, for a moment, really worried that is this like a phishing website of its own? So that's always a worry. And of course, this my dog is helping to make a point on the internet. No one knows you're a dog, okay? And so the key network security, our goals is to ensure confidentiality, integrity, authenticity, and availability. We want to make sure that you're able to identify who you are talking with. And so authentication is a very important concept, also very interesting when you talk about proving who you are. In the physical world, it's relatively simple. You show your ID, driver's license, you show your face. But on the internet, it's really, really complicated, okay? So before you log on to your email server, like someone got to be authenticated. Your email server asks for your password, but you want to make sure you're talking to the right server. So it's almost a deadlock problem, right? See, we want to do mutual authentication, but who goes first? Who goes first? I certainly don't want to give away my password if I'm talking to some stranger. So, so let's see, how do people authenticate in the physical world? And if you want to park your car, if you want to have valet park your car, you give your car key to a valet, you have to make sure this is the right valet, right? So, and so you kind of know because this person is standing next to a table that says valet, and maybe wearing some sort of uniform. And you go to a movie theater, right? You go to a theater, you give them your ticket, and you want to make sure you give to the right admission person, the gatekeeper, right? So you have to make sure this is the right person. And because you're in the movie theater, there's probably only one person who's taking your ticket. how does authentication work at DMV? How do you know that it's safe to give them your private information, your driver's license? Well, because you're in the right place, right? So there's a physical evidences that indicate this is the right authority, the service provider. On the internet, you cannot see Amazon. You don't see, the bank server. So how does this work? Right? How does it? And then in the meantime, we're dealing with the threat model where attacker can pretend to be a server, attacker can intercept, replay, and can do all kind of bad things. So we're going to discuss this next class as well. But for now, just remember, and also I want you to go back home and think about it. Who authenticate first? But short answer for now is the server needs to prove itself first. Server has to show, hey, I'm Amazon. Hey, I'm Bank of America. Hey, I'm vt.edu. I'm google.com. So because if the server does not prove itself, the client cannot release the password. And so you just need to invent a way for the servers to prove itself. Okay. And the good thing is that there are not many servers. Okay. If you think of services, popular services, there are not many services. So maybe you can list some public information about the server. Somehow in reality it's public key. But if you can make that public information on the server available, and then maybe there's secret knowledge about that corresponding to that public knowledge that only legitimate server knows. So that is exactly how we do server authentication in TLS. And that information is called a digital certificate. So if you visit google.com, nowadays it's pretty much, top servers are all just to go by default HTTPS instead of HTTP. And because there's enough bandwidth, and so even if it's encrypted, it's still pretty fast. And you click on padlock, if you use a different browser, different operating system, then it's in different places. But when you click it, you'll find a certificate. It says valid. So your browser is doing work behind the scene, validating this is actually the right Google. And so what it means that this server, this google.com, www.google.com server, possess the right knowledge corresponding to the correct public key. Okay. So, and similarly, check the key, check the certificate, and then when you open it, this is nsf.org, you will see it has a pass. It has a pass. It says, okay, verisign certificate authority CA signed some other certificate authority CA, which then signed NSF, issued this certificate for NSF, this National Science Foundation. So someone else issued this server a certificate, a digital certificate. So it's a digital document that shows, okay, address and so on. The domain name is very important. It matches, right? So if it shows like nsf.com, then it's mismatched. It should be .gov. And then if you go down, there's a lot of information that shows that there's also keys. So make sure you check the digital certificates of whatever server that you visit, and just click on it. Okay, click on it, and you'll be able to find out more information. We certainly will talk a little bit more explaining different components of the certificate. But right now, think of this as an endorsement. But it's not just one statement. It has to have some cryptographic portion of it, so no one can fake the endorsement, right? Like I cannot sign a certificate. I cannot issue a certificate for anybody because I'm not a CA. So you cannot spoof it. So that's basically TLS, HTTPS in the working, and that's essentially powering the internet. Without that, no one will have e-commerce, no one will have e-banking, and as all of you know, during COVID, online transactions are just so important. That's how the humanity continue, and so it's all because the network security, right? So we're gonna learn more security protocols, but protocol is just how server and clients talk to each other, or server and server how they talk to each other. It's steps. Step one you do this, step two I do this, and so how they speak to each other. And so as we said, that the server need to prove itself first, right? Because otherwise you will run into the dreaded man in the middle attack scenario. And man in the middle attack is one of my favorite attacks because it's just so simple. And then it's just fascinating to explain, right? So how can someone who knows nothing to begin with, and then after a couple rounds and end up being able to know everything, can pretend to be server in front of Bob and pretend to be Bob in front of server. So, and of course, in this scenario, the threat model is that attacker will be able to eavesdrop the traffic, intercept, modify, and impersonate anyone. This is the threat model, okay? And so let's just quickly see how it goes, and we're gonna review this a bit more next class, and because this is very important concept. So what do the attacker do? Follow the steps. First step is Bob is misled by the attacker to visit attacker's website, and could be because of phishing and so on. So Bob visits attacker's website, which look like an email server website, like our VT's Gmail website. VT has outsourced a lot of our mail and other services to Google. So and Bob look at okay, this has this good logo, all look good. So Bob enters his password. Now attacker says, okay, we are in business. We have attacker. We have the victim's password, and Bob is on the other end waiting for his email to show up, right? So, but then attacker has no emails. So attacker need to get Bob some emails, and so attacker visit the actual email server using Bob's password, retrieve Bob's email, and relay it back to Bob. That's it. Man in the middle in the working, right? So and what went wrong in this attack? Which step? Which number? That is the beginning of the problem. Number one, right? Bob entered his password into attacker's server website because Bob didn't authenticate the attacker, didn't authenticate that, didn't check that this is a real website. So it's very important that, you as a client has to make sure it's, double check the certificate to make sure it matches. Don't click on any random link that shows up, right? So like last time I showed this real phishing email pretending to be Newman Library and fooling a graduate student to reset her password, and so don't do it. And it's very important to know the only way to defeat man in the middle attack is to validate the server's public key certificate. Okay, so let me quickly show my browser here. So okay, so this is the VT. This is the VT website. You see this padlock, right? So let me see if I can. Okay, and then you click it. The connection is secure. Connection is secure because that the certificate is valid. And then you can click details. It shows Virginia Tech, Blacksburg. Okay, so it makes sense. And then this matches, right? This matches the domain name. And if you go down here, it says, oh, the version signature. There's a lot of fancy words here. And the algorithm. It also has a signature. Okay, this is a signature that the certificate authority signed. It's a digital signature. Digital signature is really a computation. It's signed on the hash of a message. Okay, so it's really two elements is that it endorses a statement, and also no one else can sign it. So, and if you go down a bit more, it will show the particular public key. Okay, so this is the public key of Virginia Tech, and public key is completely fine to share. Okay, it's the private key corresponding to the public key that has to be kept secret. Okay, so if you graduate from here, don't send any private key to anybody else. Okay, private key has to stay here. When I was in grad school, our system admin, that was in the early 2000, like 2002. So security was still relatively new, and so people wasn't that familiar. And so one of our system admin of the department, when they emailed the whole department saying, hey, I generated a new key for the department, attached is a private key of the department. So of course, he had to immediately regenerate a new key, because the minute you send that to somebody else, it's already not secure. And so the private key has to stay on the server. Okay, it has to cannot be shared. And so there's additional information, expiration date and things like that. You don't have to, there's a lot of technical details. So this is, there's a lot of elements that you don't have to worry about. Sometimes, it's multi-year, like a multi-year certificate. Let me see, when does it expire? And you do have to pay. You do have to pay the certificate authority. Yeah, so it's like 2 year, right? So 2 year validity period. So yeah, we'll learn more about how this works. Let me go back to the slide. So do play with it. Okay, go back home and play with it. Next class, I want to talk. We'll continue talking more about this, and this is a concept that is just I want to hammer it into you. Okay, hammer it into you, because so we're gonna talk about this again and again and again. This is how TLS works. The certificate's very, very important. So go back home and then find out all these elements. You don't have to submit anything, but do spend time to play with it. So that's it for today. Thank you very much. Bye.